Okay, starting with our last lesson of the term, our last set of lessons in lesson 14, we're just looking here at a bit of review of everything we've learned about lines. So we have slope y-intercept form. Actually, one thing we could add on here is ax plus by equals c. We call that form standard form. And then we had the slope y-intercept form, which is really nice because it gives us the slope and the y-intercept, and that's the easiest one to plug into our graphing calculators. And then when did we use this point slope form? We used it when we had a point that was not the y-intercept, right? And that's why we're using x1, y1 as opposed to 0b, because this point might be another point other than the y-intercept. How do we know that we have the y-intercept if we're given a point? What about it tells us it's the y-intercept? The x will be 0, exactly right. And then we have two special kinds of lines, horizontal, and horizontal lines have a slope of 0, and they will have a y-intercept. And then a vertical line will have a slope that is undefined and will have an x-intercept. So our vertical lines look like this. Our horizontal lines look like this. Okay, and then today we're going to talk about slope as a rate of change. And so if we simplify the slope into a unit fraction or a unit rate, we will have a denominator that is 1, and we will include units in this. So here, if we want to find the slope and the rate of change for each given graph, here we're seeing that our x's are in gallons and our y is in miles. So we'll have miles per gallon. And so if we want to calculate the slope, we can say from one point to another point, how much did we rise and how much did we run? So actually this point right here, 5, 150, I'm just looking for a place on the line where it crosses exactly because all of these other points are crossing at fractions. So if I go rise, what's my rise? From 0 to 150, what would be my rise? Rise is 150. And then from 0 to 5, what's my run? Would be 5, right? From 0 to 5, my run is 5. So if I think about my slope as the rise over run, I would have 150 is my rise over 5. If I reduce that, what does that reduce down to? 30 over 1, because 5 goes into 15 3 times, 5 goes into 0 0 times. And if we want to describe this as a rate of change, we could say we're going to go 30, what's the units? Miles. And we could actually use P for per gallon, miles per gallon. Or that's the same thing as 30 miles for every, or per 1 gallon. And we're using that as a unit rate. And that would be our rate of change. Can anyone tell me, based on this graph, what would be the equation of the line if we were going to put it together with the slope and the y-intercept? Yeah, or 150 over 5x is the same thing as 30x. What's the y-intercept? The y-intercept is here. The y-intercept is 0, 0, and that means you would have an implied plus 0. So the y-intercept is 0. Usually wouldn't write that, though, so we could just write y equals 30x. Okay, let's look at the next one. We have dollars is our y, and hours is our x. And so again, I might just say, okay, well, here's my y-intercept, so I'll start there. Another point, is also 5, 150. So that means my rise, how much did I rise? Still 150, right? How much did I run? 5. So our slope is rise over run. 150 over 5 reduces to 30. But now, as a rate of change, I want to use the units. So 30 over 1 is the same thing as 30. What are the units in my y-axis? $30, good. Per, what's the units in the denominator? Or my x units? Yes, hours. So $30 per hour. The equation would be the same, y equals 30x. Okay, any questions on that one so far? Just looking at two graphs, yes. I like that. You could do that as well. $30 per hour is the same thing. Okay, let's look at, I think we can get started on this problem. So we have an electrical utility company charges $63 for using 400 kilowatts of electricity. The charge for 750 kilowatts is $150 or $105, sorry. If 400, 63 represents 1 point, state another point. So you see what they're doing here is we're saying, here's the kilowatts. We're going to say that's X. And then the charge is Y. How do I know that? Because they're just putting it in that order. So what would be the second ordered pair? Yes, 750 kilowatts costs us $105. Find the rate of change. How would we actually find the rate of change if we have 2 points? We would use what to find the rate of change? What are we calculating? The slope, right? What is the equation for the slope? Who remembers? M equals y2 minus y1 over, good. Okay, and then which one of these is the first point? Which one of these is the second point? Does that matter? It matters? It doesn't matter. So I could say this is the first one, x1, y1. Use this one as x2, y2. That actually works out conveniently because since I'm using the second point first, and the second point has bigger numbers, I'm probably going to have a positive slope, maybe. Okay, so I'm going to calculate the slope, which is the same thing as the rate of change. We're going to go 105 minus what number? 63, good. Over, tell me what to fill in the bottom. Good, 750 minus 400. And then we're going to do this math. 42 over 350. And what does that reduce down to? If we were to divide. 112. So we have 1.12. So let's put the units with it. What were the units in my numerator? Oh, sorry, what? Oh, 0.12, yes. I was thinking that didn't make sense. 0.12. And what does that 0.12, what kind of units would go with the 0.12? What were the units in the numerator? 105 and 63, yes, were dollars. Good. And the units in the denominator were kilowatt hours. So this means I have 12 cents per kilowatt hour. What does it mean to interpret the slope as a rate of change? How would you actually interpret it? You would write a sentence. So who could give me the sentence answer for what does this rate of change mean? Yeah, it costs 12 cents for every kilowatt hour of electricity. Okay, find the equation that models the situation. So can we assume that you're starting at 0? Can we assume that the utility company doesn't charge you anything if you don't use electricity? Is that true about your bill? I actually don't know if it's true or not, but maybe it's true, maybe it's not. There could be a utility company that just charges you for service, right? And then you have your usage on top of that. Since I don't have the y-intercept, I should use the point slope form. Since I don't, why are neither one of these points the y-intercept? Because neither one of them start with 0. So let's use point slope form. Y minus y1 equals m times x minus x1. So we call this the point slope form. Okay, and then we can go ahead and plug these numbers in. So which point do you want to use? Doesn't matter, we can use either one. Why don't we just, for consistency's sake, we'll just use the first one. So we would have y minus, what number? Good, 63 equals m, what's m? Oh, that's our 12 cents. We just figured it out. X minus, what number? 400. Excellent. By the way, if you also set it up y minus 105 equals 0.12, x minus 750, you would get the same answer. So it doesn't matter which one you do. Okay, so let's go ahead and solve this. And this is where it would be handy to have a calculator. So I'm so glad I have a whole group of calculators in the room. Okay, y minus 63 equals 0.12x minus, who can tell me what do you get when you multiply 48? Okay. Yes, negative. I already have the negative side. Good. And then what would you do to get x by itself, or y by itself, sorry? Add 63 to both sides, and we get y equals 0.12x. And what's this? Plus 15. Excellent. So identify, so these are our equation, and by the way, you'll get the exact same thing if you do it this way. Identify the y-intercept. What is the y-intercept? Now that we have it in slope y-intercept form, who can tell me what the y-intercept is? Yeah, 0, 15 as an ordered pair, because if we plugged in x as 0, we would still have paid $15. Interpret the y-intercept in the context of the story problem. So what does the y-intercept mean? I think I just said it, but just go ahead and restate it. The y-intercept would mean, yes, it costs $15 even if you use 0, or maybe I'll write it out, 0 kilowatt hours of electricity. Okay?